Dear students, in this lecture we will discuss another type of flow in which there is the presence of a cylinder in the fluid motion. The difference between the first two lectures and in this lecture is that in this case the cylinder is fixed, the fluid is streaming as well as it is circulating around the cylinder. So in this case the title may be the fluid motion when fluid is streaming and circulating around a fixed cylinder. So if you see in this case we are having a combination of three situations, because your fluid is streaming and cylinder is fixed. So it is case 2 which we have discussed in the previous lecture, and to attain this situation what we did, first situation, as I said you, it is the combination of three situations. It is the first situation that cylinder is moving rectilinearly in positive x direction. So I say that this is the cylinder and this is moving in positive x direction. This is situation 1. Now second situation, fluid is streaming but cylinder is fixed, so you have to bring your cylinder to rest. So second situation is, suppose it is W1, it will be described by W1. Fluid is moving in negative, this is positive x direction, in negative x direction with the same velocity, say u, such that the cylinder comes to rest. So in previous article we have seen the combination of these two cases. So let it be described by W2. Now the next situation, third, which is important and different, that fluid is also circulating. So fluid is circulating around fixed cylinder. We know the W1 of this situation, we know the W2 of this situation, but we do not know what is the W3 of this situation. In second situation, this was your cylinder which was moving with velocity u, and fluid starts to move with the same velocity in negative direction. So this is second situation. And what is in third situation? First situation, cylinder was moving. Second situation, fluid is moving. This is fluid, this is cylinder, and this fluid is also circulating. This is third, circulation. And now you have to take the combination of all these three. This is first, this is second, and this is third. So first of all we will try to find that what will be the complex potential in case there is circulation. For that we will derive the circulation. Now we find what is W3. For W3, we need the circulation to describe. This is a cylinder and this is the circulation. So you know that in this case, this is the transverse, this is the radial component of velocity QR, and this will be the transverse component of velocity. So if we are talking about circulation, we are bothering for q theta, and this q theta is working on a line element. So how we define the circulation? We define gamma is equal to velocity dot line element. And what is this q in this case? It will be q theta. And what is the line element when we are talking about the complete cross section? This will be the circumference. So it is 2 pi r. So gamma is equal to minus 1 upon r delta phi delta theta 2 pi r, because q theta may be described in terms of velocity potential, and delta phi delta theta comes out to be minus gamma upon 2 pi. Integrating, you will get phi is equal to minus gamma upon 2 pi theta. Now using this value, I can get psi as delta phi delta theta is equal to minus r delta psi delta r. So minus r delta psi delta r is delta phi delta theta. Delta phi delta theta is delta phi delta theta will be gamma upon 2 pi. So this implies delta psi delta r is equal to gamma upon 2 pi r. Integrating, psi is equal to 1 upon 2 pi log r. So combining this phi and and psi, we will get W for circulation. So what is W? W is equal to phi gamma upon 2 pi theta plus I psi, so I upon 2 pi log r. Combine, calculate this, and after certain calculation you will get I gamma upon 2 pi log z. So this is the complex potential in case of circulation. Now I know what is W1, I know what is W2, and now this is W3. So combination of the three will give you the complex potential of the present state. What is W1? W1 was calculated as u a square upon z. W2 was calculated as uz, and W3 is recently calculated as I gamma upon 2 pi log z. So our W becomes u a square upon z plus uz plus I gamma upon 2 pi log z. This is our W. This is 1. Now with the help of this W, you put the values of z, you separate real and imaginary part, and I am just writing these real and imaginary part. You will get phi is equal to u a square upon r cos theta plus u r cos theta minus gamma upon 2 pi theta, and psi will come out to be minus u a square upon r sin theta plus u r sin theta plus gamma upon 2 pi log r. Now what is the radial component of velocity? This is QR. QR will be by definition delta phi delta r. Radial means velocity in the direction of radius. This is the radial component. This is the radial component. And what is the transverse component? This will be the transverse component. This is QR and this is Q theta. So what is QR? QR is minus delta phi delta r. So differentiate it and get QR. It is minus UA square upon R square cos theta plus U cos theta. And what is its value at the cylinder? At R is equal to A. If you put R is equal to A, this will be cancelled, this will be cancelled. So QR is 0. It simply means there is no radial component of velocity. There is no velocity across the cylinder. This is important result. Now what is Q theta? Q theta will also be calculated. It will be minus 1 upon R delta phi delta theta. So it will be minus 1 upon R. Delta phi delta theta will be minus UA square upon R sin theta minus UR sin theta minus gamma upon 2 pi. This is Q theta, or Q theta means this is transverse component of velocity or tangential component of velocity. Now we are interested in stagnation points. So what will happen at the stagnation points? First of all, for stagnation point, I have to take Q theta to be 0. So to find the stagnation point, I take case 1. If gamma is 0. In this case, you will reach to the previous case, which we discussed in the previous lecture. But in this article also, we have to show that what will happen if gamma is equal to 0. You see that QR is already 0. So Q theta is equal to, this will be 0. And this I will count at R is equal to A, that is at the surface of the cylinder. I will get R is equal to A here. R is equal to A. So it will come out to be Q theta is U sin theta plus U sin theta. That is, it is twice U sin theta. Now what will be the stagnation points? When it is 0, QR is already 0. So it is 0 at a stagnation point. So this means theta is 0 at stagnation point. This implies theta is 0 and pi by 2. 0 and pi at a stagnation point. So theta is equal to 0 and theta is equal to pi will give you the stagnation points. This is theta is equal to 0 and this is theta is equal to pi. So these are the stagnation streamlines. If I draw it, in this situation, this is x-axis and this is also x-axis. This point represents theta is equal to 0. This point represents theta is equal to pi. So along these lines, this is actually the stagnation streamline and this will be the flow line. So we can draw the flow lines with the help of the stagnation point. We are not necessarily to draw the streamlines with the help of the expression, mathematical expression. So this is again the streamline. So this is the flow pattern. This is flow pattern. Okay. It is the situation when there is no circulation. Now we come to the situation when circulation is present. So case when gamma is not equal to 0. In this case, what is our q theta? Q theta is equal to u a square upon r square plus u sin theta plus gamma upon 2 pi r. I calculate it at r is equal to a. Q theta will be twice u sin theta plus gamma upon 2 pi r. 2 pi a. This will be 2 pi a. This is 2 pi a. Or q theta is 0 when twice u sin theta plus gamma upon 2 pi a is 0, or when sin theta is minus gamma upon 4 pi a u. This is very important expression. You say this to be 3 and this to be 4. This is 4. Now you look at the picture. First of all, your sin theta is negative when your gamma is positive. Case 1. If gamma is positive, what do you mean by positive gamma? That you are taking circulation in anti-clockwise direction. That is, circulation is in anti-clockwise direction. Then, because sin theta is negative, the stagnation points will lie in second and third quadrant. If this is your cylinder, no, I should draw it. I need some space to draw it. I am drawing a very small cylinder. Okay. So sin theta is negative, and sin theta is negative something in third and fourth quadrant. So your stagnation will lie somewhere in third and fourth quadrant on the cylinder. So by symmetry, I may say that suppose these are the points. Suppose these are the points. Where the velocity comes to be 0. So what will happen? These are the streamlines. In this case, when your sin theta is like this, first of all, if I say that gamma is less than 4 pi au, sin theta lies between minus 1 and 1, and gamma is positive. So necessarily you have to take gamma to be less than 4 pi au. What will happen in this case? In this case, these will be the stagnation points. because your sine theta will have some value, theta will have some angle, theta will have some value lying in third and fourth quadrant. So these are your stagnation streamlines. Now what will be your flow lines according to this situation? According to this situation, because there is circulation, fluid is flowing like this, there is circulation as well, so your flow line will go like this. This is the flow line, these are the flow lines, and this is the flow line. Why I have taken these directions? Because fluid is coming from this direction. So it is the pattern of the flow. Here you are seeing that the symmetry which we obtained in this case, this is the symmetry of the flow. Whatever is the flow in the upper region is the flow in the lower region. So symmetry of the flow is lost. So here up down symmetry, up down. What happens at this point of my notepad? Up down symmetry of flow is not maintained. Okay. Now come to the next situation. My q theta was q theta. It was twice u sine theta plus gamma upon 2 pi a. I am still on the cylinder. Now my sine theta is minus gamma upon 4 pi au. So there is another situation when gamma is equal to 4 pi au. I have taken the situation when gamma is less than 4 pi au. Now I am at the stage when I am taking gamma to be 4 a pi u. That implies sine theta to be minus 1. So what is theta? Theta will be 3 pi by 2. Now what happens? Look. This was your cylinder. Your fluid was moving like this together with circulation. Now this theta is equal to 3 pi by 2 because it is on the cylinder. Still it is on the cylinder because it is the permissible value. So this is the stagnation point. And this is the stream, stagnation stream. If you look at the previous picture, there this was your cylinder and these were the stagnation points. Now these two stagnation points will come closer and these will meet to a point. This is the point. You are seeing your gamma is keep on increasing. In this situation, gamma was less than 4 a pi u. Now gamma is increased. It has becomes equal to 4 a pi u, and so these 2 points will come closer, and this will be the stagnation point. So how will we draw our lines? Our lines will be flow lines. This will be the flow. This will go like this. Sorry. First of all, I have to complete this cylinder, and then this is the flow line. This is the flow line. This is the flow line. This is the direction because you are taking it anti-clockwise. This is the direction. These are the directions. So it is the flow pattern. Now we come to the third situation. What is the third situation? In one situation gamma was less than, in this situation gamma is equal to. Now it may happen that gamma keeps on increasing and it becomes this is second situation, and now it happens that gamma comes to be greater than 4a pi u. If you look at this situation, and we also know that theta lies in second or third quadrant because sine theta is -1. So theta will lie in second, third or fourth quadrant. Further, if I see my theta, q theta, then it was minus ua square upon r square plus u plus gamma upon 2 pi r. And if I put it to be 0, because I have to see what is the stagnation point, I'll get the value of r which will be greater than a in this situation. So what does it mean? That this point, this stagnation point, cannot lie on the surface of the cylinder because now your r is greater than a in this situation. Because if you look at this value, it will give you the non-permissible value of sine theta. Sine theta lies between -1 and 1, and it is giving sine theta to be less than -1. So it is an imaginary point. Further, you can draw this point like this. Suppose this is my cylinder. No, it will need more space. Just a minute. I'll draw it. Suppose this is my cylinder. Then this point will leave the cylinder. So it will go somewhere here. Then this implies, suppose I give it name n. N point will leave the cylinder. And it will be your stagnation point. Now this is red one. This is your stagnation point. And what will happen? This is your stagnation streamline. This is the stagnation streamline. And how will it go, the stagnation streamline? If you draw this line, this will go very closer to the cylinder. This is the stagnation line. And what will be the flow lines? Because your fluid is flowing in this direction. Further, this is circulating. So this is a very bad picture. In this way, you will draw these lines. यहीं से शुरू करिए आप. These are the flow lines, and this will be the line. These are your flow lines. So in this way you get your flow patterns in all these situations. Now it simply means that first of all, whenever circulation is added, then symmetry of the flow disappears. And secondly, the upstream stagnation point, this is the upstream stagnation point, stagnation point shifts in the downward direction if circulation is present and circulation is positive. Suppose in the same case or in some situation you have gamma to be negative. Suppose it is negative. Then what will happen? These points, these stagnation points will shift in the upward region. And otherwise you may draw the flow patterns. So if you are asked to discuss the situation in which there is circulation in clockwise direction, you just put your W3 with the negative symbol, and then you can calculate all the things which I have discussed over here. Similarly, you can find the pressure for this flow. I'll calculate the pressure in a different way for this article. Suppose this is a cylinder, and at this cylinder N is unit vector along the normal. This will have two components, Nx and Ny. Nx will be cos theta, Ny will be sin theta. Now what is force due to pressure? It is pressure Ni working on surface S. Now what is P? P is equal to half rho Q square plus some constant. You may take that constant to be 0, or if you have certain boundary conditions you apply and get the value of this constant. I am taking the simplest case. So P is equal to half rho Q theta square plus QR square, but it is half rho Q theta square because on the cylinder QR is 0. Okay. Now I calculate Fx. If I am saying Fx, I simply mean that I am talking about its component in x direction. Naturally Nx is taken as cos theta, so it will become P cos theta, and if I put ds, in place of ds I put r d theta, then these will be for theta, limits will be for theta, that is 0 to 2 pi. Now r may be taken outside, 0 to 2 pi. In place of P you may take half rho Q theta square cos theta d theta. You put the value of Q theta, which I have calculated earlier, and solving you will get its value to be 0. Similarly, if I want to find what is Fy, it will be 0 to 2 pi P sin theta r d theta, and again putting the value of P, 0 to 2 pi, P is half of rho Q theta square sin theta r d theta. If you put the value of Q theta and solve, you will get its value to be rho u gamma. What the physical meaning of Fx is? Fx is drag force. It is opposite to the direction of flow. Opposite to the direction of flow. So it says that there is no drag force. There is no drag force. And this is called lift force. So in this case, lift force is existing while the drag force is 0. So you may also calculate force in this way in any of the article. So this is all about the motion of a fluid in the presence of a cylinder. you may be asked different type you may be asked the flow to describe in different type of situations, like you may be asked to find the flow patterns when your cylinder is at rest, when your cylinder is moving, when your cylinder is at rest but fluid is circulating as well as streaming. Circulation may be in clockwise direction, circulation may be in anti-clockwise direction. So now you can solve examples related to these articles, which are very simple. If once you find your phi, your psi, and then you can calculate pressure and all other things like the maximum velocity, the stagnation point, and you can very well draw the flow patterns. Thank you so much.